Good afternoon, good evening, good morning, whatever it may be for you. Today I'm going to go through some of these examples on how to calculate surface area of geometric figures. But I will begin by saying that these questions and these notes, these all come from our curriculum, which is through McGraw-Hill. So these are not mine, these are provided from, McGraw-Hill. So I just want to make sure that I give them the proper credit for the information. So my students have asked me to go through some of our examples, and I will begin with just talking about the formulas that we're going to use. And first is talking about surface area of a right prism or surface area of a right cylinder. An example of a right prism is going to be right here, number one. A right prism is something with a base that goes straight up at a 90-degree angle, being the right angle right prism. So another example might be, looks like a triangular prism, number five. But if I wanted to use this formula, what I would do is probably, sort of flip it over on its side, go this direction, and it would turn out that I'd have this base of a triangle, and then I would go up 90 degrees, giving me a right prism. So there you go. That's looking at it that way to where I can use this formula. And let's see here. So for the cylinder, the right cylinder, here you go. Number 7 would be a good example of a right cylinder. Again, the base of the cylinder, and then I go up at a 90-degree angle. The base of the cylinder, of course, being a circle. This, number 9, is also a right cylinder, but it's just laying on its side versus, appearing to be standing 90 degrees. So there you go. We're going to use those, and let's see, do a quick example. Let's see, I'm going to use number 3 here for a quick example of a right prism. Looking at the definition here, the surface area is going to be the lateral area plus 2 times the area of the base. That's what that stands for there. And looking at that, the lateral area is going to be, the way these materials or this curriculum talks about it is, the lateral area is going to be the perimeter of the base multiplied times the height, plus then of course 2 times the area of the base. So what does that mean, the perimeter of the base? Well, if using number 3 as an example, okay, so this is going to be, pretend I got this in the background, right? There's my back side of my thing. So here we go. Here's my item here, my right prism. The base is going to be right here. It's going to be this area. This base is going to be the bottom, of course, and I also have the top. So the perimeter around that, if, let's see here, this side is 8 centimeters, this side is 15 centimeters, so of course they have their opposite sides. So what I can do is I can say 8 plus 15 is 23. 2 times 23 is going to give me the perimeter of 46. Okay, so the perimeter is 46, perimeter of the base. Then the height. The height is going to be 3. So my height is 3. And let's see, what else did it tell me I needed? Let me see, the surface area was equal to the perimeter of the base times the height plus 2 times the area of the base. And the area of the base is a rectangle, right? A rectangle, and the formula for area of a rectangle is going to be length times width, or in this case, 8 times 15. So B is going to be 8 times 15, which is, let's see here, doing math in public is going to be a 0, carry the 4, 120. In this case, it'll all be centimeters squared. This is centimeters squared. This is centimeters. This is centimeters. Let's see here. Okay, so now when we look at this. We are going to have the surface area, filling it in. The surface area is equal to the perimeter of the base, which is 46, times the height, which is 3, plus 2 times the area of the base, which we calculated at 120. And that is going to equal then, let me see here, doing some math, 8, carry the 1, 138 plus 240, and that is going to give me, let's see here, adding those two things together, I get 8, 7, 3, 378 centimeters squared. And that is how I calculate the surface area of that right prism. Okay. Looking here at my cylinder. Now my cylinder, I'll go ahead and erase this. That was a bad example of trying to show that it was a right angle going straight up and down. The formula for my cylinder is going to be really the same. The lateral area plus 2 times the area of the base. And here my lateral area is going to be determined by the circumference. You know, before we were calculating perimeter, but now we're going to calculate the circumference of the base because it's a circle, and we will multiply it times the height. And then the base will be 2 times, and here, since a cylinder is always going to have a circular base, we know it will be 2 times the area of a circle because it's going to have a circle on top, and it is going to have a circle on bottom. So what do we need to know, or what can we figure out for this cylinder? I have a circle on top and a circle on bottom, and I need to calculate the radius. So my radius is going to be 1/2 my diameter. So if my diameter is 12, that makes my radius 6, because I am going to need that to calculate these values. And it said that my surface area was equal to, let me go back over and look real quick. Surface area was equal to 2 pi RH, all right? 2 pi RH plus 2 times pi r squared. Okay, again, we see our circumference formula, the height, the 2 times the area formula. So with that, let's see, I can see here that from there to there is my height, so h is equal to 10. The radius is going to be equal to 6. And I think that's the only variables that I'm using here for my surface area. So when I plug that information in, I have the surface area is equal to 2 times pi r, which is 6, times the height, which is 10, plus 2 times pi times r squared, which is 6 squared. Simplifying, surface area is equal to, I'm going to multiply all my numbers here, and it's going to be 10 times 6 times 2, which is going to be 120 pi, plus 36, 6 squared, order of operations, 6 squared is 36, times 2 is 72, still times pi. When I combine like terms, I get 192 pi equals. Now, in the directions, it did ask me for assume the base appears as a regular polygon. You know, I was telling my students to give me the values, so we want to simplify that. We want to multiply that out from pi. And doing that, you should end up in the calculator, ending up with 603.18, rounded up to 2603.2 inches squared. And that is how I would calculate the surface area of that cylinder. Let's see, looking at that, some of the things that I'll just go ahead and look at number 11 here real quick. Number 11, they've given me the radius. The radius is 8. So I can go ahead and use that formula. And here I will just say if, coming over here, we're going to talk about the area of a right cone and a regular pyramid. So the surface area of a regular pyramid is going to be 1/2 the perimeter of the base times the slant height, which is L there, plus the area of the base. The surface area of the cone is going to be pi r times slant height, pi times r times slant height, plus the area of the base, which is a circle. So there you go. Looking at that, we need to make sure that we understand slant height. Slant height is that length out here on the edge. That is not the height. Do not be confused with the height from the vertex altitude down 90 degrees to the base of the pyramid. The slant height is on the sides of my cone and my pyramids. So with that, I will have to calculate some of those. Let's see, looking at this information, if I look at the 3 cones they've given me, 2, I have the radius and the height, not the slant height. This is my slant height out here. The same thing goes for the next one. Number 6, I do not have the slant height. I have the height, and I do not have the radius. They've given me the diameter, so my radius is equal to half of 14, or 7. And then for number 10, I have the radius. Radius is equal to 10. My height is equal to 25, but I need the slant height, which is this right here. So in all 3 of these, we can utilize the Pythagorean theorem to calculate the slant height, because that is the hypotenuse of what would appear to be a right triangle. The radius and the height of the cone form a right triangle, so we can use the Pythagorean theorem, a squared plus b squared equals c squared. C squared being our, or c being our slant height. So in doing that, I will go ahead and start and just do number 6. So number 6, in order to calculate my slant height, this would be A, R would be 7, which is B, and then this would be C in the Pythagorean theorem. So I would have 24 squared plus 7 squared is equal to my slant height squared. Working that out, I get 24 squared, which is going to be 576, plus 7 squared is 49, is equal to my slant height squared. Combine that, we get 625 is equal to my slant height squared. Find the square root of both sides, so my slant height is going to be equal to 25. Square root of 625 is 25. And using that slant height, as we come over here with our formula, here is our formula, right? Goodness. The surface area is going to be equal to pi times r, which we said was 7, times the slant height of 25, plus pi times r squared, which was 7 squared. So the surface area is going to be equal to, this and this is going to be, 175 pi plus 49 pi. Surface area is going to be equal to 549.5 plus 153.86. So my surface area is going to be approximately 703.7 millimeters squared. Now this was rounding pi. Using pi, I went ahead and used 3.14 in the calculator. So had you done the complete, had you used pi, the symbol for pi, and not done any rounding, you would have ended up with actually probably 703.7. So there you go. That is how we would do that. Of course, you would do these others the exact same way. So there is walking through some examples on how to do these problems. Filling in the formula, identifying the formula, using the characteristics of these to work with that, to work with the formula on that geometric figure, looking here, and if I went ahead and use some more information, let's see here, manufacturing based on the amount of cardboard. I'm looking here at number 3, painting. They're painting 4 walls, so we're using rectangles, a rectangular prism, right prism. Manufacturing, they're developing a cylindrical package, so we're using the formula for a cylinder. Number 15 is camping, a tent shaped like a square pyramid. So there you go, we're using the pyramid, regular pyramid for surface area. So just looking at those, and I will just add next a quick sphere. The formula for the surface area of a sphere is 4 times pi times r squared. So this is one of the examples right here, example 7 that came out of our text. And it's asking find the surface area of the sphere to the nearest tenth. Well, here is my sphere. My radius is 7.1. So they said, hey, you got 4 times pi times r squared. R is 7.1. 4 times pi times 7.1 squared is going to give me some value. And it turns out this is what it's going to be. It's going to be 633.5. But make sure in this, if you don't put this in the calculator all as one unit, make sure that you're making sure the order of operations, what should you do first? If you do it incrementally, you should have 7.1 squared. That should be the first thing you do, enter, if you're doing it individually. Then you want to multiply, right? Multiply by 4 pi, enter. And that's going to give you your value if you're having some problems like that. If you can't put it all into one line, sometimes it's best to do it incrementally according to your order of operations. So with that, those are some examples for us to walk through. Again, this material was intended for my students to help them with their assignment following the McGraw-Hill textbook and notes. So I hope this assists, and if not, we'll talk about it in class.